The next problem we need to recognize as a logarithmic equation. That is an equation that has a logarithm in it. And the logarithm is by itself, in this case, on one side of the equation. So we can go ahead and do what we call exponentiating. What that means is we're going to take a base of 6. And on both sides of the equation, we're going to take what was on that side of the equation and put it in the power of 6. The reason we do this is so that we can cancel this logarithm out from this equation and solve for the x value that was inside of that logarithm. So in this particular example, we have an exponential function with a base of 6 here, and that is going to cancel with this logarithmic function with the base of 6, leaving us simply with a 2x minus 2 on the left side of the equation. 6 cubed, if I'm not mistaken, is 216. We need to add 2 to both sides, and we need to divide both sides of the equation by 2 to get a final answer of 109. Okay, let's check out the next one. All right, these problems are getting pretty good. What we need to notice here is that while we do have a logarithmic equation, we actually have several logs here. So as is typically the case with logarithmic equations and exponential equations, there's usually more than one way to do these problems. But one goal we might have if we have logarithms on both sides of the equation is to get a single logarithm on the left side and a single logarithm on the right side. We can actually make that happen by using the quotient rule for logarithms. And that rule for logarithms says that if we have two logarithms with the same base and they're subtracted, we can combine those two logarithms into one, but we need to divide the two arguments of those two logarithms. Okay, now notice we have a logarithm on the left side, we have a log on the right side, they have the same base. So at this point we can just drop those logarithms, completely cancel them out from both sides of the equation. And in some sense what we really did is we actually exponentiated both sides of the equation. We put a base 5 on either side of the equation, and those base 5s canceled with those logarithms. But we can really just look at this as canceling the logarithms on either side of the equation. That gives us a b plus 32 over b plus 5 on the left, and just a b on the right. Now if we want to solve for b, we're going to have to get rid of this denominator. So what I'm going to do is I'm going to multiply that denominator over to the right side. I'm going to distribute that right side. And now we recognize that we have a quadratic equation. So I'm going to get a 0 on one side of that quadratic equation. I'm going to subtract b and subtract 32 from both sides. And if we do that, we are left with this quadratic equation. And if we're lucky, we can factor. This quadratic does factor into a b plus 8 and a b minus 4. That gives us two answers, b equals negative 8 and b equals positive 4. Now while these are two potential solutions, when it comes to logarithmic equations, we really do need to check our answer when we're finished. And what are we looking for when we check our answer? Well, recall that we can't plug negative values into logarithms. So if either of these final answers, when plugged into the original equation, give us a negative value inside of our logarithm, then that solution doesn't actually work. So you'll notice fairly quickly, if you tried to plug in b equals negative 8 here, we would get a negative value inside of our logarithm right here, and we would also get a negative value inside of our logarithm here. Therefore, this is not a solution, and our only actual solution is b equals 4. Alright, good work. Let's take a look at the next one. The next problem is extremely similar to the one we just did, so I'm going to skip ahead. Let's take a look at problem number 13. And in problem number 13, you'll notice there are two logarithms inside this equation, but only on one side of the equation. So what we're actually going to do is we're going to combine these two logarithms into one, again, just like we did on the last problem. This time, these two logarithms are added together, so we're going to have to use the product rule, which says you can combine these two logarithms into one if you multiply the two things inside of those two logarithms. Now we have a basic logarithmic equation. We have one log on one side of the equation all by itself and just a number on the other side of the equation. So what we're going to do is we're going to exponentiate. When we exponentiate, that means we put a 2 as the base of each side of this equation. And each side of the equation above goes into those two exponents. The reason we used a base 2 and the reason we do this at all is because this base 2 and this logarithm are going to cancel each other out. That simply leaves us with an x plus 2 and an x minus 2 on the left, and on the right we get 2 to the 5th power, which is 32. Now to finish this problem up, we need to solve this equation. If we FOIL this thing out, we'll notice that the plus 2x and the minus 2x cancel. We just get x squared minus 4 on the left side. This is a quadratic equation, which we could use the quadratic formula to solve. But notice that there is no b term. And when there is no b term, typically the easiest way to solve these equations is to isolate the x squared. I'm getting x squared equals 36, which gives us two solutions, x equals positive and negative 6. Of course, when we check those solutions, we take positive 6 and negative 6 and imagine plugging them back into the x values in the original equation. And the question we need to ask is, do either of our possible solutions here put negative values inside of our logarithms? And unfortunately, that one does. Negative 6 cannot be a solution because it creates negative values inside our logarithms, which doesn't work. It's like a zero denominator almost. So we have one solution, and it is x equals 6 in this case, and that is going to do it for that problem. Let's take a look at one more problem in this section. Let's do it in the last video for 5.5. I will see you there.